what we can do with a source of electric current. Now this object in my hand is called as a dry cell and it generates an electric current. What do I mean by statement that it generates electric current? That yes, it has got a voltage, that is it is a source of electromotive force and it allows certain current to pass through it. Let us confirm it that this is a dry cell. It has got two polarities. This is the positive end or end of a high voltage and this is the negative terminal or the end of a low voltage. You will see here on the dry cell, you will find here negative marked at the lower end and positive marked at the upper end. It means that this is a point of high potential and this is a point of low potential. A current will always pass from a point of high volt to a point of low voltage. Let us see this by confirmation by this instrument. Let us ensure that whether it is going to pass electric current or not by this instrument called as ammeter. Amperes is a unit of electric current and it indicates the rate of flow of charges in an electric circuit. Now I will connect one end of this ammeter to this positive end. Conventionally you always connect the red end of the ammeter to the point of high potential and the black end of the device to the point of low potential, and when I join this you find that the needle deflects. What happens if I connect it in the reverse manner? Let's also see, and then you will understand why we should not do that thing. When you connect it in opposite order, you find that the needle deflects in the opposite direction. So therefore it is not going to indicate you the correct reading. But here we find the right way to connect is connect the positive terminal to the point of high potential of the battery and then the negative potential to low end of the battery, and you will find that there is a deflection in the needle which shows you that a current is flowing. Similarly, it also generates what is known as an electromotive force or voltage. This device is called as a voltmeter. Again, it also has got a red terminal to be connected to the positive terminal of the battery and a black terminal to be connected to the negative terminal of the battery. Let us see what happens when we connect it. I am connecting here the point of high potential, that is a red color terminal, to the positive terminal of the battery and the black terminal to the negative end of the battery, and you will find it shows a voltage of roughly about 1.4 volts in this case. This is an electromotive force which is required to push the electrons and to generate an electric current. So we know that this is a source of electric current. It generates an electromotive force and also allows certain current to pass through it, as we have confirmed by using a voltmeter for electromotive force or voltage and ammeter to detect the presence of electric current. Now let us see how we can apply this dry cell for getting any electrical work done. For that I have taken an electric bulb. This bulb will produce light only when electric current passes through it. As a source of electric current, I have taken this dry cell and I have connected this bulb one end to the negative terminal and one end to the positive terminal, and if I join these two ends, then I am establishing an electric circuit. To construct an electric circuit, you not only require certain components, but you also need to arrange those components in a particular fashion. That becomes an electric circuit. For a simple electric circuit, you have got a battery as a source of electric current. You have got a pair of wires to act as conductors, and you have got electric bulb to act as an appliance. Now let us join one end of this bulb to the negative terminal of the battery and other end to the positive terminal of the battery, and when I join these two, you will find the bulb will glow. Now what is happening? As in the case of a voltmeter or an ammeter, we have seen earlier, now electric current is passing through this bulb, and as a result of passage of electric current through the filament of this electric bulb, it is getting heated up and that heat is getting converted into light energy. Now I disconnect it and the bulb is switched off. Now when I connect it, the bulb ignites and starts throwing light. This is called a simple electric circuit. To make it even more simple, you have an arrangement or called as one more appliance called as a key or a switch. A key is a device which is made to either establish a continuous contact or break this contact. When the flow of electrons or charges is or current is continuous, then the circuit is closed, and if the contact is broken, then the circuit becomes open. So again we connect these two ends of the battery, one end to the negative end of the battery, other end to the positive terminal of the battery. Now since the circuit is open or broken, the bulb is not going to glow. But when I press this key here, you will find that the current has started flowing because the now circuit has become closed, and then the bulb is now glowing. So when a circuit is open, no current flows, therefore the bulb will not glow. And when I close the circuit by pressing this key, right, the current is passing and the bulb will glow. This arrangement is called as a simple electric circuit. You have got a cell as a source of electric current. You have got wires as conductors. You have got bulb as an appliance, and you have got the switch as a key. When all of them are in a continuous connection, one end of the battery is connecting to the one end of the bulb. From the other end of the bulb, it is going to this key. From the other end of the key, again the conductor is coming back to the battery like this. And when I depress the key, the circuit is closed and the current passes. When I elevate it, the circuit is broken and therefore no current passes and the bulb will not glow. We can arrange either the cells in a different fashion and also bulbs in different fashion. Let us see what those differences are. The cells can be arranged in two ways, either arrangement of cells in series or arrangement of cells in parallel, or you can also arrange the bulbs or resistances or appliances same way, either in series or parallel. Now let us understand what do we mean by arrangement of cells in series. Now here I got a combination of two cells, dry cells, and the way I have attached it here is that every cell has got a positive terminal and a negative terminal. These two cells I have connected in such a manner that the positive terminal of the one cell, the first cell, is in contact here. We'll edit. Continue. So a cell has got a positive terminal and a negative terminal. The arrangement of these two cells in such a manner that the positive terminal of the second cell is in contact with the negative terminal of the first cell. And if you want to add one more cell in series for this combination, you take the third cell and arrange it in such a way that the positive end of the third cell is in contact with the negative terminal of the second cell. Now as a result of this combination, you will find that there is only one free positive terminal and only one free negative terminal. Right? There is only one free positive terminal and there is only one free negative terminal, because the negative terminal of the first cell is in contact with the positive terminal of the second cell. The negative terminal of the second cell is in contact with the positive terminal of the third cell, and there is a free negative terminal for the third cell and free positive terminal for the first cell. Right? When you arrange the cells in this manner, you call that this arrangement of cells in series. Now what happens? Let us see to understand this. Okay. So again we'll repeat the same experiment here. You have got here an electric bulb. We are going to take one cell, join one end of the wire to the positive terminal and one end to the negative terminal, and you find that the bulb glows with a certain intensity. Now I will take two cells and arrange them in series. What do we mean by arrangement in series? That the negative terminal of the first cell is in contact with the positive terminal of the second cell, and therefore in this arrangement of two cells in series, there is only one positive terminal and there is only one free negative terminal. Now when we arrange these and connect it to electric bulb, you will notice that the intensity of the bulb is more bright, because when you are arranging cells in series, the voltage is added up. The voltage is added up. Let us confirm this by this voltmeter, that I have taken only this voltmeter. First I have joined only one cell in series, and please record the voltage generated when I connect only one cell and join it in the circuit. You find that the voltage generated is somewhere about 1.4 volts. Now I am taking two cells and arranging them in series, and let us see what happens. I am connecting the positive terminal, red end to the positive terminal and the black end to the negative terminal, and you will find that Now the voltage is close to 3 volts. So when you have only one cell, the voltage is 1.4 volts. When you have got two cells and arrange them in series, the voltage is about 3 volts. And let us see what happens when you join 3 cells in series. Again, see the arrangement. You have got first cell, to the second cell is joined in series, and you also will have a third cell also joined in series. There is only one free terminal, a positive terminal, and only one free negative terminal. Now let us arrange these wires. The black terminal to the negative side and red terminal to the positive side. And you will find that the voltage now is about 6 volts, about 4.8 volts. So you find that when you add cells in series and join them, arrange them in series, the voltage is always added up. What is the consequence of this? That when you take only one cell, you find the brightness of the bulb. You will have brightness of this bulb to a certain degree. When you take two cells and join them in series, you will find that the brightness is more. And when you're going to take 3 cells and arrange them in series, you'll find that brightness is very, very bright. Right? Because we find that more the voltage, more the current, more the brightness of this bulb. This is the arrangement of cells in series.